Hey guys, it's Casey and welcome back for part 5 of our tower defense tutorial. Where we left off is that I believe we set up some more of our tower code and we kind of filled in some of the holes that we had for our targeting. We set up our nice little function here to do our target calculations, and I believe as far as some basic shooting code goes, I believe we filled in all the holes. If we find later that we maybe missed some certain situations that it might not work properly, we will go ahead and fill them in, but for now, I'm pretty happy with that. So, as a very simple review, if we hit play, we hit eject, we can spawn some runners, our tower will shoot at one, then automatically retarget the next one and continue shooting, and we can kill our runners. That's some good basic functionality for our towers. What I want to set up now is I want to set up how we can dynamically, at runtime when we hit play, instead of having our towers already in the world, let's make a simple menu so that we can select our towers, and we will select our towers from our data table, and we will drag them and we will drop them inside of our level at runtime and spawn our towers and then have them shoot at waves. So to do that, we actually need to make a proper player pawn, I guess is the way I need to rephrase that. Because right now, our default player is what came with this top-down templates, this guy right here. We don't need that. That's really not what we're looking for, so let's delete him out of our level and just get him out of our way. What I'm going to do is I'm going to make a new folder, and I'm going to call it, we will call it our player, yeah, we'll just call it for our player, because we're going to store a few different things in here. The first thing I want to do is that I want to create a player pawn, and the reason being is that with a tower defense, the way I usually view a tower defense, if you have a different goal for your tower defense, then you might need to do a character instead of a pawn. But if we do a new blueprint class, whenever you're receiving player inputs, you don't just need an actor, you need either a pawn or a character, because a pawn is the first type of an actor that can be possessed and receive inputs, and then a character is a type of pawn, but it has the additional functionality of walking around. For me, with a tower defense, I don't, at least in my view, I don't need a character running around in the level. Really what we need from our player is that we need the ability to have a camera in the sky that we can move around our mouse cursor, move it to the edge of our screen, and then pan our camera around and start clicking on objects. For that, we simply just need a pawn because we need to be able to possess it. So let's do a player pawn, and let's call this our, and there's autosave right on time. So let's rename this, and what's a simple name? Let's just call this our player camera pawn? I'm not really sure what the best... Normally, my naming conventions, I do it a very specific way, but for these tutorials, I'm more concerned about not confusing you guys. I would normally name this... what would I normally name this? I would name this like our RTS pawn or our top-down pawn. I'm not exactly sure in this situation, but know that these naming conventions, if these are really dumb for you, you can name them something else. I'm just trying to make it the most obvious name you could possibly do. I'm not really worrying about suffixes or prefixes. I'm just going with a simple name. As I stated in, I believe in the first video when we set up our AI, whenever I set up either a new AI or a new player, I always like to make a new controller class if I don't already have one. For me, that means that we've not made a player pawn before, so I want to make my own type of player controller to control our player pawn. So I'm going to right click, I'm going to do blueprint class, and right below character we can see there's player controller, and it just says a player controller responsible for controlling a pawn used by the player. Perfect. So let's grab a new player controllers, and we will call this... Now this is where the naming conventions would have helped if I would have standardized them. We will call this our TD player controller. Maybe we should have named that our TD player pawn too. That would probably make sense. I'm not going to worry about it. So what we need to do is I want to set up these to be our defaults. So what I'm going to do is I'm going to go to Edit, Project Settings, and if we go to our Maps and Nodes, and we do right here in this top area, so let's do our drop down. We could make a new game mode if we wanted to. A game mode simply just holds really what your defaults are. So you can see here it's selected game mode, and within the selected game mode you can see there's some default pawns, some default player controllers. Let's just change these to be what we just made. So let's grab our player controller and let's do our tower defense player controller. And let's grab our default pawn class. There's no default player pawn. So let's just change our default pawn class and let's change that to be our top-down character, I believe we called that. So if we go back, nope, we want our player camera pawn. So oops, let me reopen that. I already forgot what I named it. That might be a good indication. So it was our player. So default pawn class is our player. Where is it? Player camera pawn. There we go. All right. So now what we want to do is we want to set up our player pawn. So let's open up our player pawn. And what we want to do is we don't really need a visual for our player. What we want is we want a camera for our player. So if I type in camera, let's make a normal camera. And what we'll do is we will drag this up and we will rotate this 90 degrees. So for me, I just want this pointing straight down. If you want your camera to behave a little bit differently, that's okay too. So let me drag this up in the air and let's see. Let's just try out 500 units up in the air. I'm going to clear out some of these rotations. You can see they're not quite 0. I'm just going to set these to be 0, just to zero that out a bit. So let's do that to be 0, U to be 0, 0, 0, there we go. Just when you rotate it, for some reason, it slightly offsets those values. I'm not really sure why that is. So let's drag our player pawn in the level, and let's see. That is way too zoomed in. You can see once I drag it in, you can see when I select the pawn, that's how zoomed in that camera is. Let's make that a little bit more zoomed out. So let's take our camera, let's put that back to, let's try 1500. Let's save and compile. Let's go back. That looks pretty good to me. So if we dragged our camera maybe to the edge, that's how much space we'd be able to see. I kind of like that. If we want to later, we can always move it in or out, but that works for me. So now what we need to do is we need to set up how we can have our camera pan side to side. So what I'm going to do for testing purposes is with our actor, with our player camera pawn dragged into the world, I want to go over to this right side with it selected, and I want to do auto possess player, and I want to change that to be player 0. So now when I hit play, we're instantly going to snap to that camera. But you can see I have no controls actually. There's nothing I can do with this camera pawn because we have nothing set up inside of it. So what we want to do is we want to go inside of our pawn, and now let's set up some code. So what we're going to do is we're going to set up some camera panning. I've had to do this for one of my games before, and the code is not the most sleek, at least how I've done it. It works just fine. I believe it is perfectly performant. There may be a better way of doing it, but as far as I know, this works just fine. But this is a little long, and it's not very fun to set up, so I'm actually going to have this for the first time ever in this tutorial. I'm going to have something pulled up on my second monitor, and I'm going to kind of walk through it step by step. So the reason why I haven't done that so far in this tutorial, and I've done everything off the top of my head, because I believe if I'm thinking of it on the spot and I'm working through it, I think that translates much better for me explaining it. We'll see if I can still walk through this properly when we go through this code. So I know on tick, we need to constantly be checking if we should be panning around. So what we're going to do is that off of tick, we're going to check to see where our mouse is on the screen. How we can check to see where our mouse is on the screen is that if we get our player controller, so we can right click and open space, we can do get player controller, and what we can do with this return value is that we can get our mouse position. And you can see here that it's location X and location Y. And what this means is that this is going to be how close to the X on the side of the screen are we and how close to the Y on the edge of the screen are we. What we can also do with that is that we can make that X and the Y really mean something if we get our viewport size. So if we get viewport, why is that not working? So let's get viewport, there we go, get viewport size, and it's going to give us the size of our viewport. And I believe what this means is what is the resolution of our screen. So if we're in this tiny screen, it will return how big this tiny screen is, and if we were to say play this in a new window and we were like full screen it, it would then return how big is this window size. So that's what that means. So if we come back in, what we want to do with this is we want to break this because I believe it is a 2D vector. So if we highlight it, it says vector 2D, so it means it's just an X and a Y, and what we want to do is we want to break it. And then with this broken, what we want to do is we want to multiply this. So let's see here. I multiplied it by 0.1. Okay, yes. So what we want to do is we want to check to see if our mouse cursor, how close is it to these x's, to the x and to the y? Because if it makes sense, with this x, say our screen is 1920 wide, what we want to do is that we want to check if our x here, let's say, is it close to 1920? That's what we want to check, or we want to see how close is it to 0. Another way to look at this is if I multiply this by 0.1, what this will return is that will return the left 10% of the screen. If I was also to multiply this by 0.9, that would return the right 10% of the screen, or what's greater than 90%, if that makes sense. So we're checking, are we less than 10%, or are we going to be greater than 90% as far as our mouse position? So let's set that up. We want to check, is our x greater than 90%, or greater than 10% of our screen? Am I doing that right? Sorry, this is so sloppy. No, we want to set that up with the other one. That makes sense. Yeah, we want to check, is our x greater than 90%? Or we want to check, is our x less than 10%? There we go, and then less than 10%. And then we want to do that same thing for our y. So if we copy paste these values, let's actually move this down so that we grab our x on one side and we grab our y on the other, just to make it a little bit more visually appealing. So let's copy paste that down, let's grab our y, and then we want to check these nodes again, so let's grab our greater than and less than. We want to check, is our y less than 10%, or is our y greater than 90%? And now what we have is we have 4 booleans. Wonderful. What can we do with them? Well, what we can do is we can do 4 branches because we want to independently check all 4 of these values. So let's type in branch, and what we're going to do is at onTick, let's get this away, and then onTick, what we want to check first is we want to check, is our x less than 10%? So right here, our x, is it less than 10% of the x of our viewport? Let's check. If it is less than 10%, what we want to do is our goal is to store an integer for this, because we're going to store an end kind of multiplicative value. So we want to store an integer. This will all make sense in the end, because our end goal is we need to pan our camera, and we need to know which directions are we panning our camera, and we're going to do that with some math. So what we want to do is we want to create a variable. We're going to make this an integer in a second, and let's call this pan left. And with that, let's make it an integer. And what we want to do is that we want to use this pan left. Let's say our mouse is to the left far enough to where it's less than 10% in the x of our viewport. So our mouse would be all the way over here of our viewport. What we want to do is we want to move our actor left, or our camera left inside of the world. Naturally, if our rotation is right, that would mean we're moving negative in the x. So if we're less than that, what we want to do is we want to make our pan left -1, and we'll hit that up to be true. If we're not less than 10% of our screen, we're going to make another branch, and what we want to do is we want to check, okay, if our mouse isn't on the left 10% of our screen, is our mouse on the right 10% of our screen? And that's going to be this 90% check that we have here, and let's hook that up. And if our mouse is on the right 90% of our screen, let's hit that up to be true. Now we want to multiply by 1. So you can see here that later on, we're going to have a value that we're going to be multiplying at these 2 numbers here. And if it's on the left side, we're going to be multiplying it by -1. If it's on the right side, we'll be multiplying it by 1. So what we want to do now is off of the false, let's set up okay, so let's run through some logic here. If our mouse is on the left 10% of our screen, we want to set it to be -1. However, if our mouse isn't on the left 10% of our screen, we want to check, is it on the right 90% of our screen? If it is, we'll set it to 1. However, if our mouse isn't in the left 10%, which is this branch, and if it's not on the right 90%, let's set the panning left to be 0, so that we're not going left or right. We're not doing either of them. So hopefully that makes sense. And then off of all 3 of these, now we want to set up the branch for our Y checks. So if our mouse is on that left 10% of the screen, we don't want to be checking for any of these. We don't want to be setting it again. The same goes for if our mouse is on the right 90% of our screen. We want to go right past this set to 0. We don't want to deal with it. We already got which value we wanted. So now, with this branch, we want to do the same exact thing. We want to check now, is our Y in the top 10% of our screen? I believe this comes from the top. Maybe it goes from the bottom with this. Actually, Yes, that should be the bottom. So now we're checking, is our mouse from the Y in the bottom 10% of our screen? If it is, now we want to make another integer. So we hit plus, and let's call this pan up. And if our mouse is in the bottom 10% of our screen, we want to set this to be -1. We're going to set this up just like the X. And then on false, we want to set up another branch. This will be, is our mouse in the top 90% of our screen? If it is, we want to set the pan up to be 1. And then that sets to true. And then we can copy paste that down. If our mouse is not in the bottom 10% or not in the top 90%, we want to set it to 0. And now we want one more branch on the end of all of this. And now let's check just to make sure. This is going to be for some performance reasons. We want to check, is our pan left equal to, is it not equal to 0? Let's do that. So we're going to check, is our pan left, is it not equal to 0? So were we in the left 10% of our screen, or were we in the right 90% of our screen? We want to do that. Or was our pan up not 0, which means was the Y mouse position either in the bottom 10% or was it in the top 90%? If we were either of those places, that means that we need to pan. That's basically what this check is doing. If neither of them are 0, or if both of them are 0, we don't want to do any panning. We did knots here so that it comes off true if we want to pan, if that makes sense. So is our pan left not 0, so are we going to pan X, or do we need to pan Y, because our Y is not 0, or our pan up is not 0? That's what we're checking there. And now, with these integers, we can set up some easy math, or some fairly easy math. What we want to do is we want to get the current actor location of our camera, and we want to break its vector. And what we want to do is that we want to, actually, let's not break it just yet. I don't think we need to do that. What we simply want to do is we want to add to its location if we're panning. So what we're going to do is we're going to add to it, and what we're going to do is we want to get our left and our up again. Let's just clean that up a little bit. And with our left and our up, we want to multiply both of them by a float. So let's multiply u by a float, and then let's multiply u by a float. And then what we can do if we want to, we can promote this float to be a variable, and we can call this panning speed. In case we need to change it, we can just store this all into one value. And let's set our panning speed. This is going to be on tick, I believe, so it needs to be probably a small value. We'll set it to 5 to start, and if we need to, we'll come back and we'll change that. So with that, what we want to do now is, if you think about this, if we need to pan left, if our pan left is -1 or 1, we're going to be multiplying it by 5. If our pan left was 0, this is going to come out to 0, so we're not panning left at all. And that means that if our pan up was 1 or -1, we would be multiplying it and we'd be using that. So what we want to do is we want to make a vector that we're going to add into our current location. And what we're just going to do is we're going to take our X and we are going to take our Y. We're not trying to zoom in at all, so we're not touching our Z location. And we're just going to add this into the current actor location of our camera. And then what we can do with that is we just want to make sure, well, actually we could set this up. So let's just set that up. So off of true, we just want to set actor location, and that will set up some additional checks after we test this out real quick. So what we're doing is on tick, we're checking to see where our mouse position is on the screen based on if we're too far to the left, right, top, or bottom of our screen. We're going to be saying pan up is -1 or 1 or 0. And what we're using is we're using that -1 or 1 to multiply by a base value, and that we're using that and just adding that simple little change in direction back into our current location, and then we're setting our actor location to be that little bit of change. So let's try that out. So on play, what we have is we have our camera. So you can see we actually have an issue here. When I hit the top of our screen, we're going left. When I'm hitting the left of our screen, we're going down, and so forth. Are we rotated inside of the world? We are not rotated inside of the world. So what we might do here is we might alter some of these values, or what we could do is we could actually rotate our actor if we wanted to. Do we want to do that? That might be the simplest thing to do, is that we might rotate our camera 90 degrees, and then let's see now, is that the right values? So if we hit left, nope, it's actually going to be reversed in everything. So let's rotate that again. So I'm actually not liking that we're rotating our camera to match our code, so let's just set this all back to be 0, and we're actually going to fix our code real quick. So let's open back up our code. The reason being is that since, once again, this is why I hate copying code from another project, since I'm copying this code, I believe my camera was rotated in my other game, and then that's why this code is coming back bad. So let's see, why is our code coming back bad? Let's actually see what the directions they were going. So when we're in the left 90% of our screen, we're going down. So let's check our code there. So if we hit this, let's open up our code, and what you can see here is if I kind of make this small screen, let's do this. So let's see, when we're in the left 10%, our pan left is storing -1, that's good. If we're in the right 10% of our screen, we're storing 1, that's also good. If we're in the top 10% of our screen, we're storing -1, so that's backwards. And if we're in the bottom 10%, we're storing 1. So let's switch around these values. Let's start with that. So let's set U to be 1, and let's set U to be -1. So that's a good start, and let's run our code again. So now when we're in the top 10% of our screen, we're having some issue there. Let's minimize it now. So when we're in the top 10% of our screen, we're going left now, and we're in the bottom, we're going right. So now we're all kind of messed up. So we really have issues here. So let's check our code. Why are we having issues? So pan left is using our X. So let's check something real quick. I believe that is right. Is this farther X? No, that's our Y. Okay, so our X and our Y are backwards. That is the issue here. So left and right is our Y. Forward and backward is our X. That makes sense. So let's open this up, and we could rewrite all of this, but maybe the easier thing to do is just swap this around. I hope no one's offended by that. If we wanted to, actually no, that's fine. No, that is because that is panning up and that's panning left. No, that is perfectly fine. We're not fudging any code there. That is perfect. So now our left goes left, our right goes right, our down, perfect. There we go. So what was happening is I believe we were backwards with the 10%, 90%. I believe the 10% was actually returning the wrong direction, I believe is what we had there. That's why we flipped the 1 and a -1, and on top of that we had to swap our X and our Y because our pan up was doing X and our pan left was doing left and right, obviously, and that's our Y. So now our panning, I believe, is good to go. And that might be a little slow, so let's actually up our panning speed. Let's actually try this in a new window so that we can do this with a full screen. Yeah, that's a little slow. Let's just up that value just a little bit that we stored, this float that we have here. I'm just going to set that to be like 7 just to speed it up just slightly. So now we can pan left and right. That looks pretty good to me. The zoom, if we wanted to, we could zoom it out a little bit more, and that's really easy. Once again, we just go to our camera, and we need to, if we wanted to, we can visualize it in the viewport, and let's just set that Z, let's set it up to 2000. Let's just do that. Let's give us a little bit more space so that now when we hit play, yep, we have a bit of a better view of our game. So now we have our player pawn set up. So let's check how long have we been in this video. We are 20 minutes in. I think we can set up a little bit more code. So now with our players set up, let's set up some UI. So let's set up a very, very simple UI. Let's make a new folder, and we will call this UI. And let's make a user interface and a widget. And what we're going to use this UI for is we're going to use this to select what towers we want, and we're going to place them, and then we're going to use this widget to select what tower we want, and then use that to place it in the level. So let's make a widget, and let's call this our tower selection widget. And let's open it up, and let's make, at first, we will make this super simple. If we want to, we could come back and make this a bit prettier, but for our purposes, for making functionality, I really don't recommend making it perfect to start. I think what ends up happening is you start with perfection, you will probably come back later and change your mind about something, and the amount of time that you spent making something pretty and perfect probably is going to get overridden. So for base functionality, we just really want 2 buttons to start, and let's make our first button, let's put some text inside of it, and let's call this our bush tower. So let's call it bush tower. And let's copy paste this button, and then we'll drag this one slightly off to the side, and we will call this our chair tower. So I'm going to click on the button, and then with the button selected in the top, I'm just going to call this bush button, and then we're going to go to the other button, and I'm going to rename that to be chair button. And then let's stop there for a moment, And let's add this to the player's viewport. So what we're going to do is we're going to put this on a button press. I want it to be that when we're inside of the game, at any time I could press a button and I could bring up our widget. So what we want to do is we want to set up a new player input. So let's go into project settings, let's go into input, and under action mappings, let's make a new input, and we'll call this, let's call this widget. We'll just call it widget press. Naming conventions, depending on how you want to do them, you will often do some different naming types here, but for us, widget press is fine. And let's set this to be the keyboard key of Q. Let's use Q, that sounds good to me. So with that, we have it set up, and now we have a new input event called widget press, and we set it to be Q. So if we go back inside of our player pawn, what we can now do is if we right click and we type widget press, you can see we have our input event. So let's do this on press. Let's create our widget. So we can type create widget, create the widget of our tower selection widget, and let's add it to viewport. Adding to viewport, if we just created this widget, nothing would happen with it. If we don't do anything more with it, we will never be able to see it. Adding to viewport is just adding it on top of the player screen. You can see it adds to the game's viewport and fills the entire screen. The reason being that this exists is that there's some different things you can do with widgets. You can put widgets in smaller spaces. You can attach widgets to things. Here, we just want to fill the entire screen with it. And for future purposes, I want to promote this to a variable, and I want to call this our widget reference. And we will hook that up. And what I want to do is I want to check to see when we do press this button, do we currently have a widget reference? So I'm going to do is valid. And if we do not have a widget reference, we're going to create our widget. However, if we do have a widget reference, I want to take that reference and do remove from parent. Remove from parent is how you remove widgets from the screen. It's basically a way of deleting widgets is really what that does. So in the game, the reason why I did this is that if I press the widget button and it pops up onto our screen, so it's going to say, do we currently have a widget reference? No, let's add it to the screen and let's store that widget as our reference. If I press that button again, it's going to come and say, hey, do we have a widget reference? If we do, I want to delete that widget off of our screen. It's kind of like a toggle. In case we accidentally pop it up, we can press the button again to delete it, or to remove it from our screen. So that's what that does. So with that, let's hit play. I'm going to go back to selected viewport. And now with that, let's hit Q, and you can see it pops up onto our screen. But you can see how it doesn't really behave very well inside of this viewport. If we do new editor window and we full screened our game and then we hit Q, you can see it behaves a bit better, but it still isn't perfect. So what we want to do is a little trick that I've learned, and what we're going to do is we're going to make this scale to the size of our screen. So we're going to right click our canvas panel and we're going to do wrap with size box. And now you'll see a size box pops up over top of our canvas panel, and then we want to right click our size box and do wrap with scale box. And now with that, we just want to go into our size box and we want to do two things. With the size box selected on the right side, you can see we have a width override and a height override. Let's click both of those, and we're going to set, I'm personally going to set my height override to be 1920, and I'm going to set my height override to be 1080, and that matches personally my monitor's resolution. And really what that does is that helps size the widget. During runtime, it's going to get the scale of our screen, or it's going to get the size of our screen, and it's going to scale the widget to match the 1920 by 1080 resolution. Personally, that's what I want because that's the size of my monitor. So if I hit play, and now we hit our widget button, you can see now that that widget now scales much better instead of popping out of my screen. That's what I want. There's also one more thing that we want to do that I've noticed, is that you can see that when I hit play, I have my mouse, but if I accidentally click, you can see my mouse disappears. That's not really good for a tower defense. So what we want to do is that on tick, that's not very good. Let's see. We want to, let's actually fool around with something real quick. I think if we set our input mode, with our input mode, No, I think we don't want to change our input mode, because our input mode would change our ability to press buttons, I actually believe. So on tick, let's just get our player controller. Get controller. No, we want get player controller. There we go. And then let's do off of this, let's set show mouse cursor. And with that, let's just hit our check mark. And I believe this should make it so that we can never click off the screen. After this video, I'm actually going to go do a little bit of checking, because there is something called set input mode. And if we check set input mode, so you see there's set input mode game only and UI only. These are ways to lock your mouse onto the screen, but I'm afraid that some of this might override some of our game control. So I'm actually going to do a check afterwards. For now, we're going to use this code, but I'll go do some research after this and check to make sure that this is correct. We might change that over to be one of those input modes. But now when we hit play, I can't click off of the screen. We can go left and right, and if I hit Q, we can click our buttons and we'll never lose our mouse. So now what let's do is let's set up our buttons. So, actually, should we move this to the next video? Let's move this to the next video. So what I'm going to do is, between doing this next video, is I'm going to go make sure that that last piece of code is correct. And we'll come back and see if we need to change this. And what we're going to do is we're going to set up so that when we click either of our towers, what we're going to do is we're going to create a transparent tower on our mouse's location. Normal tower defenses, when you say what tower you want to build, when you drag your mouse in the world, you have like this translucent tower that once you find where you want to put it and then you click, it spawns the tower in the world at that location, and that's what we're going to set up next. And I believe from there, we're going to be pretty close to having a nice functioning tower defense. We'll be able to, at the start of our game, when we hit play, we'll be able to use our menus to build some towers. We'll be able to say when we want to spawn our waves, we'll set that up too, and then we'll have our waves of enemies come, and we'll have the towers that we create at runtime shoot at our enemies. So we're getting awful close, guys. So I hope you guys stick around and you can finish up these tutorials.